Hello, and welcome to today's episode of Rawkode Live. I am your host, Rawkode, and today we're going to be taking a look at TektonCD, a continuous build, pipeline, delivery software thingy-majiggy for Kubernetes. Before we get started, I just want to say thank you to my employer. I work for a company called Equinix Metal. They are a bare metal cloud. They provide the time, the resources for me to invest in this show and get experts from the cloud native community to come and share the technologies they're working on with us today. So thank you, Equinix Metal. If you want to try it out, you can. There's a $50 code, Rawkode-live. This will get you roughly 100 hours of compute. So it'll allow you to get a feel for what bare metal is and how to leverage it best for your cloud native architectures. Now, today, for looking at Tekton, I am joined by Kevin McDermott. Kevin is an engineer at Red Hat and a contributor to the TektonCD project. Hey, Kevin, how are you?
Hey, David, I'm not doing too badly.
Awesome. Do you want to take a few moments and tell us a little bit about yourself, and then we'll start talking about Tekton?
So I work on GitOps at Red Hat, building out automated pipelines to allow you to automate build and deployment into production. I've been writing software for over 30 years commercially, so I've been around the block a few times at different companies. But most of the stuff I write nowadays is really centered around helping people get software from idea into production as quickly and safely as possible, at least theoretically, at least.
Awesome, cool. So why don't you start by telling us what is Tekton?
So Tekton is a project. It's been around for, I think, 4 or 5 years now in its basic part of it. I don't know, maybe not, maybe 2 years in its basic part. And what it does is it's a kind of cloud native, Kubernetes native pod scheduling. So what do you have a problem with nowadays? If you want to run a container in Kube, then how do you get another container to wait for that container to execute? You can't. Right, it's pretty difficult. You have to do something with kube events or something. So Kubernetes Tekton allows you to specify the order of things, and you can split and rejoin processes to allow you to set up a series of events and containers to be executed on a PVC or something like that. So maybe if you want to build like a build pipeline, then you obviously have to clone your source code. You might want to run some tests, and then you start to build on top of it. So if you want to have a continuous delivery pipeline, then Tekton is a cloud native way of doing it. It's also the kind of basis for some other projects. So there are folks like Jenkins X and things like that who are building on top of it.
Okay, so I mean, one of its use cases is continuous delivery. Does it also tick the same box, fit in the same market as other services like regular Jenkins, like Circle CI? You know, does it have I guess a crossover in feature set with these ones, or is it slightly different because it runs in our own Kubernetes clusters?
So how is it different? So I think the biggest difference is that it isn't by itself a CI system. It's a way of executing containers and getting the results of those containers. So you don't get the kind of and this is, like, it's not intended to be like this at the moment, and there is ongoing work, but you essentially get the results of executing those containers. So for example, like obviously I work for Red Hat, so we have OpenShift, and we have some kind of nice UIs around showing you like the results of those, and we kind of gather up some results, and you can see like what pipeline, what has executed and things like that. And as you'll see that there is a Tekton dashboard which allows you to get a kind of nice visual representation of this.
All right. Well, I'm looking forward to seeing this. Tekton is one of those projects that, there are so many projects in the cloud native ecosystem, and I want to be able to play with them all, I guess, like Pokemon, but it's just finding the time. So I'm really glad that we get to take a look at this today.
Yeah.
Okay. Sorry, Nico, what were you going to say?
You know that when you open up that CNCF landscape image, and you just think, whoa.
I mean, I like the size of it now because I'm like, cool, I'm not going to run out of content for this show for a while. So, selfish reasons. But certainly as an end user, someone that has to operate stuff in production, it can be a little bit intimidating. But, Tekton solves a lot of problems, and I'm hoping we can demonstrate that today. Well, you can demonstrate that today. I just get to sit and enjoy. All right, before we get started, we do have a couple of comments. So first, hey, Andreas, how's it going? Wave, wave, wave. And Rain. Hey, Rain, how are you? Okay, so let's cover one of the things I like to do at the start of this show is just say what was prepared up front. And I like that to be as little as possible. Now, nobody wants to watch me provision a Kubernetes cluster, so that has been provisioned up front. And I have shared the kube config for that with Kevin, who will be driving most of the demo today, and batting away all my questions at the same time, I'm sure. I'm going to share your screen. Oh, we got...
Oh, that's okay. We will there we go.
Caught you off guard. There we go. So can we zoom in on that terminal a little bit?
Sure.
My eyes are good, but they're not that good.
How does that look?
I would go another 6 or 7 presses, maybe.
Okay.
A couple more if you can. Yeah. Well,
okay. Let me see if we can do this a couple more.
I know it's going to make it a little bit.
Yeah, like that wasn't too bad, is it?
I think that should be okay. If anyone, yeah, I think that might be okay. Yeah.
Okay, so what I'm going to do is, basically we have a blank cluster provided by David. So what we're going to do is I'm going to go through the things that you need to have installed. So native things all have, a big bunch of YAML to get installed. So the very first part I'm going to install this is just coming from the Tekton release documentation, is the pipelines part. So pipelines is slightly more mature than triggers, and so we can easily do a simple kube control apply, and it will source all those resources and get them coming in. Oh, nice, the VBO and clusterable role bindings. That's probably something we're going to have to fix at some point.
So this is version 0.18.1. Is that what we consider stable? That's safe for production? People, yeah, okay.
Yeah. I mean, it's not 1.0 yet, and there's no guarantees around stability. So the next thing we're going to install is triggers. So pipeline is basically your sequencing mechanism. You as you'll see, you can define tasks and you can define pipelines, and then we can execute those. Triggers is more about how do you drive a pipeline. So I'm hoping that we'll get to today actually having completed driving a build and push of an image to Docker Hub based on a change to GitHub. So let's see if we can get that far. So that's what triggers is doing. So it's bringing in a couple of CRs. So it has, I mean, as you're going to see, this is pretty YAML heavy. There's not a lot of niceness in some of this, which is why. And then the very final part of this I'm going to grab is the dashboard. I'm going to do this. So we've got our dashboard going in. So dashboard is nice, as you can see. The UI for it looks quite tasty. So I know we were talking about getting an ingress available for this. I don't know if you can do that. If not, I'm very happy to kube proxy it, because kube proxy is quite nice.
Yeah, I think we'll be kube proxying.
So don't worry, you're going to have to do. We can do this very small because you don't actually have to see this screen. So there you go. That's fine. So let's kube proxy. And if I go here, then we should be able to see. Yeah, there we go. So there's dashboard. So we've got, as you can see,
Can you zoom in on this as well, please?
Sure. Is that readable? Yeah.
No, I can't read it yet.
Get some new eyes, dude. We're at 200%. Or maybe I'll bring my screen size. No, maybe not. Right, can you see that? Is that reasonable? Visible?
The menu is not readable, but the rest is. So I think we're okay.
The menu's not readable.
Yeah, it's just a bit small, but it's okay. I think we're okay just now. There's not much to see. Oh, there we go. That's perfect. Right. 300 is where we need to be.
Okay, so very first thing I'm going to do, second thing I'm going to do rather, is create a very, very first task. So this is going to be a very simple task, which I'm going to put into a file. So vim, hello. So let's look at this. So it's a kube CR. So we've got this API version, part of the GVK stuff. So API version, kind and task, metadata name. So obviously name it. I'm going to put it in the default namespace just now, mostly because it's kind of simpler to work with. And this task is a single step that just has a name called say hello, because you got to have a name for these things. It's using Alpine, which is kind of obvious, I guess. And in this case, it's using a script. So this gets executed as a shell script on the inside the container that you pick. So we have let's get shell inside Alpine, and we're going to run this. So let's see. So I save this and do a K. I know you hate K apply, but that's okay.
No, it's K create. I don't like K apply is okay.
Okay. Right, so we've got our creation. So the next, so we have this thing. So we can see if we go to dashboard, we're going to see we now have a hello world task created 10 seconds ago, and it hasn't yet run. There aren't many runs for it, so it's not particularly exciting, but that's okay. So next thing I'm going to do is I'm going to create a really simple task run for this. So after this gist and all of the materials will be kicking about either in or in my GitHub. I'll just open up the repo that this is coming from. So let's create a hello world task run. So the relationship between these is, it's kind of like a class and instance type relationship if you're a programmer. So you have like a task defined, here's the things that need to get executed, and the task run is an instance of that particular one. So if you're familiar with Kube, you'll see that I've got a generate name on this. I don't need to have a generate name if I wanted to create, but then I'd have to go and delete it every time I run it. And this basically just is a really, really simple thing that says, go and execute the hello world task. You can see there's just a task graph. What we can do is we can do key, create. There's a reason for it. You do need to use create with generate name, I think. So what we're going to see here is if I click on this hello world task, you can see that it's doing its thing, it's pulling it, and we can see that it logged out hello world, right? Pretty much what we expected to see. So that's a really simple case, I think, right? It's a kind of traditional from KNRC book that we've got hello world as our thing. So we can also, there's a command line component part of this, and it's installable through Homebrew. It's installable from the binary releases. And so we can do TKN start hello world task. Oops. Oh, task start. Oh, if I could actually type.
Nobody can type with people watching them. That's just the rule.
So TKN task start, and so you can see that that's just created a task run and done the exact same thing. So we go to our pipeline runs, our task runs here. We can see that we've got our second task run, and it's not going to do anything different, right? So we can do that. TKN is nice because you can do things like task run list. See this, because these are really just Kube resources, so it's fetching those. And the thing that I like the most about this is you can do task run logs last, and it will go and fetch the most recent task run and get you the logs from those things. And this applies to pipeline run as well. So we've seen that you can basically do a really simple task that's doing something, nothing terribly exciting in this.
Okay, can I just summarize that back and tell me if I got anything wrong there? So what you've done so far is defined in a YAML a task. A task just needs a container image, which we're using Alpine. We give it whatever name we want, and then you have this script, a property in the spec called script, which can run any command that can happen inside the image.
Yeah.
That doesn't do anything by default. That just creates a definition of a task. And then the second thing that you did via the TKN, we call it Tekton? TKN? I don't know. Is there an official pronunciation? In fact, there's something I didn't ask you as well. What does Tekton mean? Let's answer that in a second. So you then have a task run, which can be applied via YAML or via the Tekton, I'm going to call it Tekton, command. And that actually takes the task definition, runs it as a pod inside of a container, and then gives us the outcome of that. That's kind of what you've done so far.
Yep. So that's pretty much it. Basically, your task definition is your class definition, if you like, and your task run is an instance of that class, and it executes whatever the behavior that was in the class. That's a kind of simple way to think about it. Obviously, there's not a direct analogy, but task will not deviate from a task. Sorry, task run will not deviate from a task. So tasks that do one single thing are not actually all that useful, I don't suppose. So what I'm going to do here is I'm going to update this task. I'm going to give it a parameter, because sometimes you just want to right. So I'm going to add a parameter. So you can see that I've added a single parameter. It's called name, because hey, we're going to greet someone here. It's a string type parameter. The default is world, because traditional. And we can give it a description, so we can see like who is it, what is it, what's the purpose of this particular parameter. You can name parameters any which way you want. and you'll see there's a bit of a variance between them. Some people use lowercase and some people use uppercase. I tend to use a mix, sometimes usually to differentiate between parameters that are the same, because you may be coming an input parameter and an output parameter, but you can choose to name them any which way you want. And so you can see that on line 16, you can see params.name. So what that's going to do is when it gets, when the task run gets created, when it's setting it up, it does a param replace. And so anything that's getting pulled in as a params.name thing here, that will get replaced with the value of the parameter. It's just a string replacement. It's not any more advanced than that. Does that make sense?
Yeah, that makes sense. I take it that's just interpolating an entire script and dropping in all those parameters before runtime, right?
Okay. Yeah. So we can now do tkn task start hello world task. And you can see that it's going to say, like, can you give us a value for the parameter name of type string? So you can create this with a pipeline run. So you can obviously do it in a task run rather, and you can put it in explicitly into the YAML. But tkn allows you to prompt for those things. So you can see that it's offering me the default is world, but hey, let's put in Rawkode in there. Okay, awesome. So we can do tkn task run logs last. May not have completed yet. Oh yeah, it has. Awesome. Right, so you can see that we've got this hello Rawkode, and that's kind of expected, right? So tasks are really kind of simple, but a task can have multiple steps. So let's kind of look and see where we're going next with this. So we can create a task run, so we can pass this in if we really wanted to do it, but we're not going to do that. I'm going to try and shorten this. So let's add an extra step to our task, right? So a task doesn't have to be just one thing. It can actually have multiple. I don't even know why that's jumping a bit all over the place. Let's do hello world task.yaml, and we'll add an extra step in here. What's interesting about it, I guess, the thing that caught me out the first time I had to do this was that it uses a different image for each one. So these are obviously completely separate pods on top of this. So you're going to see what this gets generated out as, but we can use the same parameter again, and this will get executed as a couple of different pods. So if I do tkn,
I think your YAML's invalid.
which actually,
I think name, image, and script are all indented one space too many.
Yes, you're absolutely right. See why I was kind of worried about YAML.
I always worry about YAML.
Professional YAML developer. Right. So we've got our task redefined. So let's do a restart on this. And let's do a live demo. It will, of course, get passed through. And should see. Hasn't completed probably. There we go.
There we go.
Things. Okay. So, and of course, if we go into dashboard, you can see your tasks coming up here. There's the duration of them, and you can see, which particular pod. And these just get executed as pods. So
does it show you the parameters that were passed to it as well?
Good question. I know tkn does. If I do tkn describe last, definitely you can see. So there's your parameters there. Does this show you the parameters? Let me see. It would be on. Oh yeah, there you go. It's on the actual task. It's not in the container, so you can actually see those things. And you can keep them about because obviously they are pods. So if we do like pods, you'll see that we have one pod for each of the. And so there's some of those, as you can see, hello world task run 227z5 has two containers within it, and that'll be the hello and goodbye containers.
Oh, so those actually ran as multiple containers in a pod concurrently and not one after the other?
No, they run one after the other. They do. We'll come to sequencing in a little bit, but these actually wait. It uses the downward API to do detection of when the things are going to execute. But as you'll see in a bit when we get to like sequencing of pipelines, you actually need it. For example, if you're going to have a git clone task before you run your build, you really need to make sure that the clone is completed before you start to build your code. So we'll have a look and see how that actually happens. Okay, so where are we? So the other format for this, so we create a slightly different task here. The other format you can use, what I expected to do autocomplete. I don't know. The other format that you can use is you can put like a kind of traditional YAML array type approach to it, so you don't have to use a script, so you can actually execute a very specific command with a specific set of parameters. So I do group create and task start execute ls. What did I call it? You did. Oh, did I not do it? Execute ls.
You did a cube create within Vim, but I'm not sure what that did.
Maybe I didn't wait for it to complete before I did it. Let's make sure. Yeah, okay.
Yeah, there you go.
Probably. So we can put in, so let's put slash in here. In logs last. Finish probably. Yeah, there we go. So just exactly what you would expect, right? We just executed, and as you can see from the task definition, it's just the same as everything else. The parameter interpolation is just getting put into the array slice of this. There are some complications around this. So you can have like one of the types you can have is an array types parameter type, and you kind of have to go and pull out the specific elements, or there's some weird stuff around like expansion of array slices of or slices arrays of strings, but you can also it's able to be, you can go and fetch the specific one if you want to go and do those kind of things. So yeah, it's pretty trivial. So that's like, you know, just so you know yourself, like you're going to have pod definitions or whatever you're doing. So an easy way to think about it. So that's that.
We have a question, if you're happy to take that just now.
Go for it.
Andreas is asking if we'll be covering the options for building container images.
Yes,
we will.
Yes,
all right, stay tuned, Andreas.
We'll see how. Right, so we're going to use buildah to do it later, but I'll show you. We'll get to that. So there's another thing that we have called this. This is some. For files that I'm creating. So let's look at this one. So this is so the difference here is you've got this thing called a result. And the result is something that you, when you execute, if you write to the path of the result, then whatever you write there is available to other tasks. Now, this is a single task, so it's not so exciting. But for, like, as you'll see in a bit, like when you clone a git clone, when the official git clone task, it writes the specific URL and the SHA of the commit that it cloned to results, which you can then use later on. So, for example, you might want to build something that references those things, and so you can do that. So this case here is a really simple example-ish. It takes a repo and it goes to GitHub and it then uses JQ to work out what the most common, you know, if you go to, I don't know, if you go to /languages on a repo, then you get this map back, which is the strings of all of the languages, you know, when you go to GitHub and you can see it. So this will go and do it, and we'll put out the top language. How useful this is? Probably not all that useful, but let's so let's actually wait for kubectl to complete this time. There we go. Right, so let's do tk task start top language task, and you can actually pass parameters. So we can do repo equals, give me a repo, something you've got on GitHub.
Rawkode /.files. No, slash in Rawkode /.files, not actual the word. Yeah.
Okay, let's see.
Can you hit the wee hide on that screen share thing just so it doesn't blur the text?
Yeah, it annoys me as well. Oh.
Thanks.
There we go. Right, okay, so we've got our task run, in task run, logs last.
You should say ginger.
So it's done it, believe it or not. But we do tk in task run describe last. You should see that. What language are you expecting it to be?
Ginger. Shell. Oh, I guess there's shell in there too.
Right. So according to, so what it does is it goes and like if you've never seen JQ is fun for doing this kind of stuff, but you can say like 2 entries, sort by .value -1, take the last one, and then get the key of that. So like you get 2 for today, you know, you get to learn how JQ works if you're really keen on it. And it goes away and fetches that and gets you. So your top language in your repo is clearly shell. So you
So this is using something on a task called a result. What are the primary use cases for that? And is that something we use to pass the other task definitions? Is it something? Is it logged differently in the UI? Like what do we use results for?
Use them for a couple of different. Mostly, it's about getting things between tasks in a pipeline. But you can. Oops, if I remember to actually get the right thing here. If I get my task run, what was my task run? You can. I mean, because it's a standard kube resource object, you can do this, and so you can. If you wanted to run something and then get a structured result from it, you can do that. So we can get our value back as shell. But yeah, I mean, it's essentially just writing a value in that you can then use later in a type line. So for example, you might get an auth token, for example, for something. So you might want to write that to the result and then pick that up and use that for auth in subsequent requests. Because you can, as you'll see in a wee bit when we get to pipelines, you can actually reference results specifically as parameter and put them into parameters to be then called by subsequent tasks in the pipeline.
Okay, so we actually have another question that aligns really well to what you just said there. Then Andreas is asking, is there a way to put in secrets into our tasks so that we can access secret information from Kubernetes or even file amounts?
Yes, there's a couple of different ways to do it. We're going to see a secret getting used later. This is something that, I'll be honest, especially pipeline it's not great, the support for doing this for reasons that you'll see in a bit. And there is a plan to kind of make this a little bit better. There's a big kind of discussion about making secrets better for pipelines before 1.0, I guess. But you'll see how that works in a bit. I promise we're going to get to doing a secret. Right, so I'm going to create a very simple pipeline. Okay. This pipeline here. So let's look at what this has. So this is a pipeline called demo pipeline. It takes one parameter, type string, and it only has one task in it, right? So it's using the task that we were using earlier, called hello world task. It's a task. You get two types of tasks. You get cluster tasks and you get tasks. And unsurprisingly, the difference between those is one is cluster level and the other is namespace level. And you can, so for example, how you build your Docker images and things like that, those probably don't vary very much across different environments. So you probably want to make those as a kind of, or the GoLint code or any of the things that I'm going to, maybe a lot of the tasks I'm going to show you today could be cluster level tasks. But for the specific case, we're just going to keep them all in one namespace and have some fun that way,
Yep.
I guess. And so one of the things I'm going to say is, see that params part in the task reference, so just below the task. So what that's actually doing is it maps a parameter to the pipeline to a parameter to the task. So you'll notice that I deliberately called the parameter to the pipeline message. And what it does is it takes that message value and maps that to the name parameter to the task. Does that make sense?
Yes, so our pipeline has a parameter called message, and we're passing that into the task as name.
Yes. So it means you don't have to have like the same names. And this is a really common thing throughout Tekton. There's a whole lot of things that use remappings, like workspaces. And so many of the things, basically, you say like, here is this value. And I'll be honest, it looks complicated at first. And if you don't understand the exact reason for it, it's twice as complicated probably. But really what it's all about is you don't need to have standard naming. And you could have pipelines that are upstream, have upstream tasks that you just use and you map how you want to make your parameters pass through to those. Okay, so this is our very first pipeline. So this is, there we go. Okay, so we can create what's called a pipeline run. And to be honest, TKN is creating pipeline run. So I'm going to probably create a pipeline run. Oh no, I'll do it like this way. We're going to get to pipeline run in a second. So pipeline start demo pipeline. It's going to complain, so probably, yeah, it's going to ask me for the message. So let's do our TKN pipeline run list, because we should see it, so you can see that it's running. And we can do logs last, and this should There we go. Awesome. Right, so it's just executing that task. We go into our dashboard. We get to see our pipeline runs for a change. And we can see this particular pipeline run here. Yeah, so that's it there. And all it does is one task and it passes that parameter through to it. So it's kind of really simple. Pipelines basically provide sequencing for tasks.
I don't know if it's something you're going to show later, but it popped in my head, so I'll say now. Can we modify the task definition, and can we make it fail? Just for the giggles.
Yeah. How could we do this? Let's think. What would actually cause it to fail?
Let's just change the task to run a command that doesn't exist, like instead of echo, let's typo and echo or something, right? So
yeah, let's do LSX.
Yeah.
I don't think there's a command called LSX, is there?
No, to my knowledge, no.
Fail.
Yeah,
definitely not. Yeah, maybe actually. Yeah. So apply. Come on, yeah, okay, there we go. Right, so let's we run that pipeline and you'll see what happens. So we start demo pipeline. Let's just put demo and see it in the I think there we go. Awesome. Right, so it failed because a pipeline will fail if any of its tasks fail. As soon as a step it returns a non-zero exit code, then it fails.
I must admit, I can just get the logs out of that, see why it failed. Like it's all self-explanatory, I would imagine. So
it's actually quite nice because you can do if you do TKN pipeline run last. See what it actually says here. So it says like, steps basically with code 127, blah blah blah. To see the specific logs for this, I must have this in a real because it's so big, it's getting taken off into the screen. If you're on a normal screen, what actually happens here is it shows you the kube control command to display it. I don't even have a scroller across on this for whatever reason. My term's great, except for when it's not.
You can just show it from the UI, I guess, right? I mean, that message will be there too.
Yeah, you'll see the thing there, but there you go.
Yeah, perfect.
So exactly what we expected. If you modify it and you get it's fairly visible. You can see the nice kind of red thing here. So this is looking a bit better. Okay, so now we're going to start to get into the image and the other bits of it that folks are probably really keen on. So there is a catalog of tasks available. So Tekton has this a whole big catalog with about 5 different build mechanisms. There's buildah, S2I, and build packs, and various other things in here. So these are kind of predefined tasks. And if we go and look at the git clone task,
can you zoom that to 300%?
Yeah, thank you for reminding me. So you can see that this has like 0.2 and it has 2 things. So it says here this task has 2 required inputs, the URL of the Git repo to clone provided with the URL parameter and a workspace called output. Okay, so we can see that these are the 2 things. And we'll talk about workspaces when I set this up to do it. But basically a workspace is, I'll say you last, I'll do it. A workspace is kind of shared space. So it's a PVC that's getting defined and that task executes. So this is why you can't use an empty-dir, because if you did, you would end up with multiple empty-dir PVCs getting created. This gives you kind of persistent storage. It's bound to the lifetime of the pipeline run, to be fair, but it allows the tasks to carry the things. So obviously, if you git clone, you probably want to act on that git clone that you've just cloned. So what this allows you to do is to write it out and then have another task come along and pick that source code up and do the right thing. So there's a whole lot of parameters. I'm not going to go into all of them. You can see that you can provide revisions, ref specs, submodules, depth, SSL verification, which I think should be as insecure as I don't like to see SSL verified. what it tells you and what it means is really different. You can set up proxies and things like that. So you can do a lot of different things in this. So what we're going to do is we're going to take this is the YAML for it. It's quite a big task. I've looked at it a few times. Come on, go to there. You can see it's got 132 lines, probably not what you want to look at. So I'm going to grab the raw version of this.
So the way that we consume tasks from the catalog is really just to apply them rather than like reference them within the YAML itself?
Yeah, because it's going to be names. There is a couple of things. So pretty sure TKN has support for fetching them from the catalog. But there's also like bundle work going on, some quite exciting stuff going on that's allows you to like bundling to like add all of the various pieces that you might need for a task. So there we go. So we've installed our new git clone task, as you saw from the catalog. And so what I'm now about to do here is I'm going to build a pipeline that uses this. Okay, so let's then go to build source. So there's a bit of promise if ever I heard one. Build source pipeline. What you're going to see is that it takes two parameters. I've made them capitals, mostly to help differentiate between the things that I'm passing in and the things that the task needs. You'll notice that the task said it needed a lowercase URL and a lowercase revision parameter. So my pipeline takes git repo and git ref, and it takes those and will execute the task. You can see that it creates this, it uses a thing called a workspace. So this is like a declaration. So this is, I say that this pipeline has a workspace called shared data. But again, this mapping thing that we talked about, like workspaces, name output, workspace, shared data, that's me saying that the git clone source, which is using git clone, it should get this shared data workspace, but they want to call it output for their purposes. So that's cool. We'll remap shared data to output for the execution of this particular task. Okay, so that's like basically a pipeline with a single task just now. And all it's doing is cloning that git repo and putting it in. So I'm going to build the source. I'm going to do it like this. It should work. Oh, yes.
Oh, you didn't apply the pipeline. Right, okay.
So it's, handy error. So name for the workspace, shared data. This, I'm going to make it an empty dir for this one because we don't need to carry the source across. So it's an empty dir, isn't it? I think this will work. Okay, so it's going to go and grab the git clone task and do the right thing. You can see that it has completed. Awesome. Right, so not particularly useful as a start, but log slash, you'll see that we awesome. Right, so that's stored in there, and that's our first problem whenever you want to build something, you need to have source code somewhere. Okay, so one of the things I'm going to show, we talked about earlier, is task results. You'll see what they're useful for. Slightly bigger. So I'm going to add an extra task in here. And so this is two things, right? So this new task is called echo results. Number be easier to people to read. 26, you can see echo results. And so what you'll notice is I've explicitly put it to run after clone source. And I'm happy to take that out and show you what happens if you don't put run in after. But you can see that it's taking two parameters, the commit and the URL. And it's got a script that just echoes the two values, right? So nothing particularly remarkable about this particular thing. But it takes its parameters to the task. So this is like an embedded task. I'm not referencing an external task here. I'm referencing an embedded task. And it's going to take those two parameters. So you see the way that this is referenced here. So this tasks.clonesource.result.commit. Unfortunately, the only way you'll know this is by looking at the task that you're executing. But this is saying that line 14, task clone source, it has a result called commit, and I want to be passing that in as a parameter to my echo results task. Does that make sense?
Yeah, I mean, I'll try and summarize that back to you. So this is another pipeline with multiple tasks. I think what's different from this one is that instead of using task ref like we do in the clone source one, we've got a task spec. The task spec just allows us to define a task inside of the pipeline. There's then access to a variable called tasks dot, and the clone source is just the name of the previous task, and then we can access the results and then the commit and then the results and the URL from it. So it all kind of links together via the task name, and the task spec is a nice way of doing that inline. I mean, is task spec something that you see people using for their pipelines rather than defining the tasks separately? Is there any kind of preference there?
So truthfully, I guess it depends on whether you consider a task to be reusable or not. Like for some things, so why did I put a task spec in here? Because basically I didn't want to have to write another YAML file and apply it when I could just jam a task spec in. So that's what it boils down to. Like, I guess if it's reusable and if you, and it's easy enough to refactor this, so you can just extract it and make that task spec the spec of a task definition that you're writing. So nothing would be particularly different here, and you would just, the only thing that would change is task spec would become task ref and whatever you name this.
Yeah.
So it's kind of really, it's a useful trick. It's, I guess the pipelines that I kind of, when we generate like pipelines all the time for this, we kind of try to mostly task ref, but for some cases we would task spec it. And if you've tried my TektonCD thing, it generates huge YAMLs with all embedded tasks and pipeline runs and everything. So what I'm going to do here is I'm going to do a kube apply on it. I should have done when it was in Vim, but there you go. Okay, and I'm going to run that pipeline again. Works, but we'll see how it goes. In task run logs. And what I'm going to do once this finishes, I'll go back and show what happens if you don't put run after, because this is sequencing, right? So you need to wait for the first task to finish, generally. And so TKN pipeline run. Oh yeah, so you can like pick from here. That's quite cool. Should see, and there we go. Right, so our task is executed, and all it says, you can see, it's just echoed the two values that we were expecting to get here. So it's nothing remarkable, I don't think, about that. Okay, so we're going to start to get into building an image from source. So there's another task in the.
Do you want to remove that run after first, just so we can see?
Oh yeah.
I was excited for that, and I felt like you were going to take it away from me there.
Right, so we do this, and I use Vim for everything. So let's just apply that. There we go. Let's do that run again. Oh, damn it. I don't know why it doesn't just default to that. It's possibly a bug. Right, so we're going to do this. I think it will now in a really weird way. I think it's a bit confusing because it's not obvious. Like if you, oh yeah, TTN task, last, echo get result, and I did get it. I think this may just be. Let me see. Oh, did I actually reapply that thing after I changed it?
I don't recall.
I think it may just be lucky.
So is there a race condition without the run after? Okay.
Yeah, you can get into it. That's how you avoid race conditions. So buildah is this new task that we're going to use, right? So buildah takes a Git repository that has a Docker file in it, and it builds it and then pushes it to a Git repository. So this is kind of really, sorry, it's an image repo. So you can see that you've got to get an image, you override the buildah image, the path to the Docker file. So that just kind of assumes that it'll be in the top level of your repo. You can pass a whole lot of extra parameters and arguments to it. So for example, if you want to add, what we use this for is for doing extra labels on an image. So if you want to like label it with a commit and who committed and the details that you maybe get in from a commit here. So you can see that this is going to take a source and it's going to work on top of that. So I'm going to steal my, oh yeah, I'm going to do it like this. So first of all, I'm going to do the apply. So catalog. Okay, awesome. I'll need a secret in here. Okay, so I've got a secret created. And what I'm going to do for this is I'm going to grant access to that secret. It's a Docker config secret type. So I'm going to add this to the default service account, which is probably not that great, but anyway, we'll come back to this soon. And I'm going to, so let's build source pipeline. So let's look at what we've got now. We have a task clone source, and we have a task build image, and build image runs after close source. It references the task, the buildah image, and it takes our param image that we want to do, and it's pretty simple stuff. Buildah, as I say, just takes your Docker file and runs a thing called buildah, which is our bud rather, which is a tool for building images inside containers.
Yep.
So if we do k replace deviation for kube control to k, and let's run this build. I need a secret. The reason I need a secret in there is because I want to push the image to KubeMD live demo latest. That should work. Yeah. Okay, now this might take a little, in fact, will take a little bit of time. Sure. It's up there. So you can see that this is parameter missing. Oh,
dun, dun, dun.
Oh, I know what I did wrong. Well, so let's see what this says then, right? Let's TKN. I know actually what the parameter is. I'm screwed up. So at last, you can see it's missing the image param. So pipeline run default parameters is missing some parameter. Is missing some parameters required by pipeline source image. So if you look at my command line, -p is how you specify each key value parameter, and I've got a p on it there. So that's cool.
So it keeps asking you for the workspace, the subpath. I mean, is there a way for it to not ask that?
So I don't know the way of it on TKN. So the way I normally do this is by creating a pipeline run, just as I did with the task run earlier, and you can then do the whole thing, and then you're just kind of creating it because it doesn't change over the life cycle. Oh, there's a nice typo there actually, which I hadn't noticed before. An empty. Yeah. Okay, we'll maybe fix that. Yeah, except if someone TKN pipeline run logs last. Still running, so this might take a little bit of time.
Oh yeah, I mean this is actually building a container image with buildah now, right? So
yeah. I mean, it takes maybe it'll take about a minute or so. Oh no! Wrong. Logs. I feel I know what it is. They get clone succeeded.
No Docker file?
Yeah, right. So I know what it is. So this is, I'm going to build, we do need a pipeline run for this because it's multiple containers. I think this is really just a limitation of TKN just now. I had a conversation yesterday, someone didn't quite get what I was going. So, so what I'm going to do here is I'm going to write I've got a pipeline run ready for this. Okay, so let's do build source pipeline run.yaml. What I'm going to do is here, I'm going to create what's called a volume claim template, and that's what it really is a way to claim a bit of your PVC space. Right, so I'm just going to grab a gigabyte. Sorry, dude, if you get more than, if you get less than that, we're in trouble. Change this to push it to it's going to do all the same things, right? It's not any different from the PV, except for this is going to provide PVC backing. And if you think about it, empty DIRs are for the lifespan of the pod. Because we have multiple pods for each of the steps or each of the tasks, then we are create -f, almost like a pandas in advance.
So we have a question which I think fits in with what you're doing right now as well. So just to clarify, the PVC template, the shared data PVC that we're sharing across the pipeline is specific to that run of the pipeline. Is that right?
Yes.
Okay. So Andreas is Sorry. Andres is just asking, is there a way for us to actually have global state that we can inject into multiple pipelines for cache libraries? I guess like composer caches from PHP, PyPy from Python.
Yes, you can. So you don't, if you don't use a template. So there's two different ways to specify a volume for a pipeline run. You can be explicit and actually just reference a volume, and the git clone task will allow you to git clone even if the content already exists. You can provide a parameter option to that. So you could share the same PVC and do a git clone, and then cache. Say you're using Node or something like that, you could cache the results in with that. So yes. You've either got templates which are created and are tied to the lifespan of the pipeline run, or you have a fixed volume and you can just mount that in any pipeline run that you want.
Nice.
So let's see, where are we? Where are we? We're still running. Wow, quite impressively fast hardware you've got running there, dude.
Bare metal is the only way to run Kubernetes.
I'm not even doing that for so let's go. Oh, I'm going to have to log into hub.docker.com. Here, this is not going to be fun. Okay, you just have to trust me on this. There's a pushed an image. This is because I created a whole new profile so that I didn't have all my history. Not that my history would really roll here.
This is actually pushed to the Docker Hub, right? With your credentials. I mean, you don't need to show us that, but I guess you just created a secret inside the cluster that Tekton has access to.
Yes,
okay.
That's why I created that earlier. So basically, you create that here. You saw the thing when I did it, right? So you can do it here, right? So create a secret from home Docker config JSON, right? So it needs to be a Docker config JSON, and Tekton will automatically make sure that that's available as your config JSON, which is your auth to pushing up to GitHub, not GitHub, to Docker or to whatever your thing is. And so it essentially takes the secrets that are associated with the service account that's actually doing the work. And we'll bind those things. So it's kind of fairly simple. So we got our image. I mean, as you can see, it didn't take all that long to build. Did all of the Docker file compilation, and we're good to go there. Okay, so that's there. So I'm going to do one other thing here, right? So what I'm going to do is I'm going to add a test task in. Right? So what did I call this? Go test task.yaml. So it's because generally you don't just build code, you probably want to lint it beforehand. So what I've got here is a really, really simple go test task. So what does it do? It does a mod setup to make sure that all of our things are pulled. It runs govet, it runs CI-lint, and then it runs go test on the source code. And so if any of those things fail, then we want our pipeline to fail, right? We don't want to build the image if the code's not good. So what I'm going to do is, I'm going to do kube create. Okay, so this is going to create that task for us. And then what I'm going to do is I'm going to go to the pipeline, which is the build pipeline. I'm going to here. I almost do this one by hand. But then if I screw it up, I'll spend 10 minutes trying to find the right. So let's put this in. So I've said that check source should run after clone source. And it just maps in the thing here. But what I want build image to do is to run after check. So, okay, so we've got the sequence. We're saying that clone it, check it, build the image. That make sense?
Yeah, pretty standard build process, I guess, for most people.
Yep. Okay. Yeah. Okay, so now we'll just we'll create a new pipeline run. Yes, here. Do TKN task. This should hopefully fail. Yeah, nothing failing test, which I'm going to use to show how GitHub. And we're doing okay for time, I think. Yeah, 10 minutes. Maybe we'll get there. First.
So can you just run kube control get task run? That also works, right? I mean, these are all just CRDs.
Yeah.
And we get there. Yeah, it's cool. I like it.
Yeah. So, I mean, they are just CRs. TKN is nice because it gives obviously some localized knowledge to the actual output of the things, but ultimately you can just do the right thing. So let's see, where are we? Oh, that was a task run list. Oh, yeah, so it's still running. Surprise.
I guess it's doing a bit more this time, isn't it?
As well.
I mean, is there a way for us to find out what task it's on right now within the run?
Yeah. Should be able to see. Awesome. Right. So our code is broken. Deliberately so, I promise.
Your code is broken. Mine's is fine.
Okay, my code is broken. So we'll come back to fixing this once we start to go down the event listener route, and we'll see how by pushing this, we can trigger a new build automatically. So it's easy enough to insert tasks into the pipeline. And what you'll notice is if we look at it, that it didn't execute the image build, right? So you can see that it did the clone, it did the go vet, it did the go test, and then it failed at that point. And if we go to the dashboard and look at our pipeline runs, you can see that it builds source pipeline and it has failed. So you can see that it got where it got to and which bit failed. It's quite nice. Dashboard is nice, TKN is nice. Almost all of these things are just providing views of the kube resources, as you can imagine. Okay, so all that's quite cool. So what do we want to do next? Right, well, we're going to look at an event listener. And event listeners are part of Tekton triggers, so they're the kind of other side of this. So the very first thing I'm going to do, because I'm going to cheat a little bit here, right? So I'm going to grab this permissions.yaml. Really, this is permissions to allow Tekton to execute containers in the default namespace. Otherwise, you'd have to go into Tekton pipelines namespace. But there's reasons for it's just easier to cheat like this. So I'm going to do a kube control apply. You can go and grab the permissions if you want to see them. You're just going to see it's a demo role and a demo cluster role and a demo role binding and a demo service account. So nothing tremendously remarkable here. So what I'm going to do is I'm going to grab this event listener. So let's look at what this is. So this is an event listener. So an event listener is basically a way for ingress for JSON bodies to come in and to trigger something. So what does it trigger? Well, in this case, there's no filter. Okay, so we just get this thing that says whenever you get something that comes in, use the bindings, which we're going to see in a second. In fact, I should probably bind them all together in one file. Oh, no, I won't do it like that. Yeah, you can see how that could go badly wrong. So we've got this binding and template. So once you see what a binding looks like, these make a bit more sense. I'm going to steal this thing here. Binding.yaml. So metadata, demo binding. And so this is our named binding, which we referenced in the event listener. And so this says, whenever you get it, go and extract. So what we're going to do here is this thing here, body, is a JSON path specification. So this says, go and get the body, which is provided as the JSON, whatever the HTTP body. It only works with JSON though, because let me remember, it doesn't support anything other than JSON, yes. So this is, look, the JSON body that you receive will have a message key at the top level on it. So extract that out into a parameter called message. All right, so that's kind of obvious what that's doing. And then we're going to create this template. So templates are a bit weird because they are very powerful, but also so what this says is that this template needs a parameter called message. It's just a description message. I was really bored earlier, you can tell. Right. So we've got resource templates. And so the resource templates are, think of these like YAMLs for pipeline runs and things like that. And the only difference is they get dynamically evaluated when the trigger is executing correctly. So in other words, and what it does is it extracts the values from the event listener. So let's it's from the binding rather. So let's demo binding. So it extracts that and then it puts it into the pipeline. So this thing here, TT, so trigger template.params.message. Okay, so it's going to call our demo pipeline from earlier, the one that didn't do very much. It just passed through hello world, and it's going to apply a pipeline run for it and extract the body from some JSON body that we're going to fire at it and execute that pipeline. So instead of doing like TKN run and providing a parameter, we can do the whole thing. So let's do K, apply -f demo template. This is going to be boring, and you can see why I was thinking about doing it. Demo binding and so I don't remember. We've now got this thing. So let's do K get all. K get pods would have been better. actually services would have been even better. So we can see that we've got this EL demo event listener here.
Yep.
Okay, so it's listening on port 8080. And so this basically waits for HTTP requests to come in. So what I'm going to do is I'm going to very quickly do another very key port forward. You'll have to be able to read this one. Service EL demo event listener 80. Should do, yep, okay. And what we're going to do is we're going to curl to send the body. Okay, so you can see that this is going to do content type application JSON. Message is coming from JSON to HTTP localhost 8080. Okay. So if we now TKN pipeline run list, should see, oh, we broke it earlier, didn't we?
We did.
And we didn't put it back. Okay, well, here we go, a bit of debugging now. TKN pipeline run, describe,
Probably still trying to run the fail-rawkode command.
Absolutely right.
So we have a couple more comments while you fix that then. So first Thomas says, hey Thomas, nice to see you. We then got Vincent who says we can pass -F to follow the live logs of a task run, pipeline run, I guess, which is cool. And then Andreas is asking, is it possible to run buildah without being a privileged container? There is rootless buildah, so it is definitely possible. However, I'm assuming Vincent maybe works on the Tekton project. He's also just said that there's some limitations with the current version of the task, but that's about to change. So it sounds like rootless container image building with buildah is coming soon, which is cool.
So params dot name, I think we're getting. So what's the key?
I should have made you break that task earlier. I'm sorry.
No. Debugging is hard. So we're going to get our TKN pipeline run. This, we should see it being successful this time. Right. So this time, as you can guess, because the JSON says from JSON in it, we're going to do TKN pipeline run logs last. And we should see. Okay, so if we do a quick get Vicky logs deploy EL demo event. You can see what it actually logs out. So, and this is for debugging, right? So you're getting up debugging things. So it says here, like it created a resource Tekton dev v1 beta resource with a message name from JSON. You can see that this is the kind of resource stuff. If it fails, you will get messages in here complaining bitterly about whatever the problem is that you've just triggered. And usually the one area that it can be difficult to debug is if you're not totally familiar with the body, the JSON body that's coming in, and you're going to come. I'm going to come on to showing you some more like cooler bits of this. We'll go for another 5 minutes and see how far we get. So basically, we have it like running pipelines from things. So there is a thing here called the GitHub interceptor. And what it does is it takes like GitHub push events and allows you to auth them, and then decide that you only want to run on a push event. Okay, so what we can do is we'll see how we go for time here, right? So make it a very quick one.
So this just means that we can use this GitHub interceptor that whenever we merge to the main branch, we send something to Tekton, which triggers the trigger.
Yes, so this here says use the demo account. So what this is going to do is also going to validate the webhook comes from GitHub. Right, so like the secret name and secret token here are ways of saying that that webhook GitHub can sign the body of the request, and so it sends you a push event. So this kind of thing here says make sure that it's coming from GitHub with our shared secret, and it's a push event. And we're going to use a slightly different template and binding. So let's go with a binding here. We called one of the nice things about this though is that you can make this kind of compatible with multiple upstreams, right? So if you think about it, GitLab uses pretty different JSON bodies, but it's the same values that were like a commit and a URL are the kind of things we're going to get from it. So you can actually kind of write a standard build template, but how you get the parameters to run that template can be different. So we've got our, so this is basically like body head commit ID and body repository clone URL. So these come from this. So you can see like, if we look at the push event, commit ref.
Can you zoom in on that just a little bit more?
Yep, there we go. So let's see what we get. We're getting body.head commit. So if we look at head commit, you can see that you're going to get like an ID coming.
Yeah.
So we're going to get the SHA and the get repository URL. So we're going to look, we'll get clone URL. So that's, we actually get it from the hook event that's coming in if we want to.
Yep.
And the last part of this work here, and we're hoping to get this build finished, so we can successful build, will be build code template. So this here, I think, there we go. So this is a template that is going to extract the, oh, yeah, there we go, that's okay. I'm just checking something there. So this is going to extract the image, the repo, the ref from the hook request, and then put the image. You can't vary it here. You can with a more advanced thing that I'm probably not going to get time to get to today, but that's okay. But you can actually use like cell to extract some of these fields and then use that to work out which image that you wanted to actually traverse to. But we can see that we're going to get some bits extracted from the binding, and it's going to put it in. Okay, so what I'm going to do is get event listener. I'm going to delete that event listener so I can, and then I'm going to bring it in and then we'll see if we can get a build from a push with GitHub.
Cool.
How long we got? 2-3 minutes? Okay, so wait, EL demo. Cool. So create, let's do, create build code template. Right. Oh, F in it had been even cooler, wouldn't it?
Yeah.
So create -f GitHub push binding and create -f GitHub event listener. Remember that the GitHub event listener is really just, the only difference between that and the previous one is we've got this interceptor that's saying like only allow GitHub requests that have a valid secret and that are push events to come through here. Okay, it doesn't have support for picking out branches or any of that kind of thing. You can do that, don't worry about it, but not with the GitHub secret, not with the GitHub interceptor. And what it says is like, and so an interceptor basically says, if any of these return an error, then don't use this trigger. And you can have multiple triggers. So this can be duplicated as many times as you want with different templates and different bindings, and you just detect which one you care about and then execute. So all of the ones that where the interceptors don't reject the request will execute. So if you've got like 50 triggers in there, then 50 could actually start to execute at the same time. But probably you don't because you filter them out.
And I can write my own interceptors. Is that a thing?
There's support coming in for that actually. To be honest, Cell will probably cover about 90% of your use cases. So there's a Google expression language called CL or Cell. I'm going to run the service that was running. So you can do it like that. So let me just do a quick ngrok. Oh yeah, that should be okay. I'll restart that. What I'm going to do is what's my ngrok port here? It's not. It's get services. Let's see. Type that. Fine.
Right now, Kevin's just ngrokking because you want to be able to have the GitHub event go to your machine and be forwarded onto the Kubernetes cluster because I gave you a Kubernetes cluster with no ingress.
Yeah, but don't worry about it. It doesn't make you a bad person, dude. So let's go demo. let's go to like, this is so big. It's really well.
It looks great for us though, Kevin. So
Awesome. For me, it's like wait. So let me. Oops, accept. Yeah, that's fine. So let's do this. Payload URL. So this is, as you can see, just a standard webhook thing in GitHub. So what did ngrok get me? It got me. Did I run ngrok? Yes. Let's grab that. HTTP. Here's in the darkness. There we go. Come on. Oh, jeez. This is hard. There we go. That there. Or not. That's it. Got it. Okay, so I'm going to pop that in here. Endpoint. I'll leave it secret because I happen to know what that is. And so this is just like, push events and things like that. So that's going to be cool. So if you remember rightly, there was a bug earlier in the tests. Remember the code that was failing to do it? So what I'm going to do is I'm going to do git checkout -b fix demo. And vim package demo handler test. I'm going to say this was written for another things you can tell. So what I'm going to say is if Redis URL equals empty t.skip. I'm going to make this return empty if there's nothing. Just I don't really care about it. So let's go test. Make sure that actually runs between the data there. So if I get into it, that's cool. Right, so let's do git add dot git commit -m live demo.
Fix stuff.
Yeah. Push. It's going to complain. Get push. I should really set there's an option for that.
Yep.
I had it at some point, and then every time I change machines. Right. So I've just done a push. So if we go to our webhook in giant form, we should see a recent delivery. Excellent, right? So that means it's sent the push on to ngrok. Ngrok will then take that and forward it to your bare metal cloud thing. And now, if we do tkn pipeline run list, yes, awesome! It's building the source, right? So tkn pipeline run logs. This is going to take about what 40 seconds or something like that.
Add the -f flag and we'll follow it along. Let's see if that
good
works.
point. Yeah, thanks. Yeah. Can we do that, I wonder? Awesome. So you can see that it's going to run the tests and see the fail maybe or not. Thank you, Vansel. It's worth chatting to you yesterday then. Right, so our tests are now passed.
Test is passed, yep. So it's going to do the build.
Yeah.
There we go. Nice. Very cool.
So we're at 15:19. That's not too bad. We'll probably finish it at that. If you're really keen, I can do a second parallel. There's all the others like Excel and stuff like that. But an hour and 15 minutes is probably long enough for most people's attention span. This is going to go and get registry API, and we can fix that.
Yeah, that's awesome. Really, really cool.
Right, so we just pushed the enemy. So what we did there was we configured Tekton to receive. So let's go back and have a look at our things. We have a GitHub event listener. So it will check for pushes and it will validate the incoming hooks. It then hands that off to the GitHub push binding. So it's just pulling out the commit and the clone URL. That then goes to the GitHub to the build code. I tried to call it that to see that it really is kind of generic. As long as you can get a git ref to it and a source URL, then it can create a build for you. So you can see that then passed through and did the right thing, creates a volume and does all of the things. So this is let's go look at our dashboard. We should see our pipeline running here. There we go, one build source. So it took about 1 minute and 39 seconds to build. It's not too bad, actually. And that's including all of the checks and things like that. All right.
Perfect.
So we did get to building source code from a Git push, which was what I was aiming for. Trust me, I had like pile of stuff like cell interceptors, debugging, VS Code. VS Code is quite nice on this. You get like some pretty cool UI, shows you all the tasks and the pipelines, or what I believe is a pretty cool UI if you like VS Code.
Is there anything else you want to show before I pop your screen off?
No, I think we'll
all right.
quickly.
So that was awesome. It was really cool to see Tekton working start to finish, including that GitHub webhook coming in, building, pushing, all of that, the PVs for carrying the state, the sequential ordering. Lots of really useful information there. So thank you for putting that together. For the people watching, the Gist and the repositories that Kevin's used will stick in the show notes, so you'll be able to follow along. And I think we can just finish with a very brief question then that we didn't ask at the start is, what does Tekton mean?
So it's apparently ancient Greek for like craftsman or artisan. So like, got to keep a Greek name for things when you're building a Docker thing. Either that or some weird ship related. So they opted for an ancient Greek for craftsman.
Yeah.
Which is kind of nice.
We must be running out of nautical puns for names for products by now anyway. So, all right. Well, thank you very much. I know we went a little bit over. I think you've taken time out of your day for that. So just, thank you very much for joining us, for sharing that. I hope you have an awesome rest of your day, and I'll hopefully speak to you again soon, Kevin.
Thanks, Dave. Take care.
Right, thank you. Cheers. Bye.